Gane Engine, devlog, visual evolution, and render optimizations. Intro, Joss Hook. Hey everyone, welcome back. Today, we're taking a huge leap forward in the development of the Gane Engine. Following our initial baby steps release, I've been focusing heavily on the rendering pipeline to make the engine's world look significantly more realistic, cinematic, and, most importantly, seamless. In this video, we're diving into how we eliminated the horizon line, tamed aggressive light blowing, and implemented a cleaner way to showcase the engine. Let's jump straight into the math and the code behind these updates. 1. Decoupled Atmospheric Fog System. One of the biggest visual immersion breakers in previous builds was how harsh and artificial distant objects looked. To fix this, we implemented a decoupled atmospheric fog system. Instead of applying a generic global fog, we split the logic entirely between the terrain and the ocean. Volumetric haze for terrain. To prevent distant mountains and terrain geometry from popping out aggressively, we integrated a realistic neutral gray atmospheric haze handled by the day-night manager. This gives the world a much more organic sense of depth. Specular horizon sky merge for the ocean. This was the trickiest part, but easily the most rewarding. Previously, there was a sharp, ugly boundary line where the ocean met the skybox. To solve this, we added a distance-based blending factor, fog factor, directly into the ocean shader, ocean.frag. Now, instead of fading into a flat gray fog, the distant ocean smoothly blends into the sky's own reflection color, riffle color. The result? A flawless, infinite ocean illusion. 2. Specular clamp architecture. Another major rendering artifact occurred where the sun met the water. At certain steep angles, the specular brightness values would mathematically spike toward infinity. These extreme values were actually piercing right through the distant fog, causing ugly, pixelated light blowing that completely broke the render pipeline. We tamed this by introducing a strict upper bound, a clamp architecture, directly inside the lighting calculations of ocean.frag. Now, specular highlights are strictly capped before they can corrupt the pipeline, keeping the water reflections perfectly balanced and cinematic. 3. Render distance and fog optimization. Frustum, fog sync. If you've ever worked on a game engine, you know that screen edge tearing and sudden object pop-in are absolute nightmares. In Gane Engine, we had a synchronization mismatch between the physical maximum distance the ocean was being drawn, render distance, and the point where the fog became opaque, fog start. By pulling the fog start value down from 800 to 200, we synchronized it with our Frustum culling. Now, right before the engine physically clips and deletes objects or ocean vertices out of the view frustum, they are already completely masked by the fog and sky reflection. This completely eliminated that distracting edge tearing, giving us a massive boost in both visual smoothness and performance optimization.